Hello students, welcome to this video. In the last session, we have learned about the bubble sort algorithm. Okay, in this video, we are going to learn about the insertion sort. Okay, insertion sort algorithm. Okay, let me start with one example, then only you can easily understand this concept. Okay, let me consider an example. The number of elements we have, that is 44, 16, 83, 7, 67, 21, 34, 45, 10. Okay, these are the elements we are have. Okay, first step is, if it is the first element, it is already sorted. 44 is already sorted. 44 is already sorted. The sorted elements is in the form of sorted sublist. The second one is unsorted sublist. Okay, the remaining elements are called unsorted sublist. Okay, first of all, we can pick up the first element. Okay, that is 16. Okay, the first element. Okay, the first element is pick out from this list of element. Okay, the first element is pick out, that is 16. The 16 is compared with the 44. The 16 is a small element. Okay, 44 is a big element, so we can interchange the position of these elements. Okay, 16 is being here, 44 is being here. Okay, so now 16 is in the correct place. Okay, 16 is placed in the first place. After that, 44 is placed on the second place. Okay, this is in the correct form. So the next step is, pick next element and compare with all elements in the sorted sublist. Okay, now 16 is a sorted element. Okay, after that 44 is after the interchange of the element 44, the set of elements are take it as a sorted sublist. Okay, these are the unsorted sublist. We can divide the second value as a sorted sublist. These remaining elements are unsorted sublist. Okay, first, now shift. Now we can move to the step 3. Shift all the elements in the sorted sublist that is greater than the value to be sorted, then insert the values. Okay, now we can do this step. Here 44, 16. Okay, we have two elements here. Now we can pick out this element, that is 83, from the unsorted sublist first element. Okay, now compare this 83 as the first element of sorted sublist. Okay, here we can compare the element in the right to left position. Okay, because here we have two elements here. Okay, first of all, 83 is compared with the 44. 83 is a big element. Okay, compared with 44, so it need not any change here. After that, we can compare with the element 16. After the comparison of 83 and 16 means 83 is a big element, 16 is a small element, so we need not do any change here. So this in the correct form of order. Okay, now we have these three elements in the perfect order. Okay, in the next step, we can divide this position. Okay, we can divide this position as a sorted sublist. Okay, sorted sublist. These remaining elements are in the unsorted sublist. Okay, Okay, sorted sublist, unsorted sublist, this is in the correct order. So repeat until list is sorted. This is the procedure to sort the element. So we can see the element 83. I already told you 83 is in the correct order, so we do not need any interchange the element in the correct position. Okay, this is in the correct order, so we can move to the next step. '83 is in the correct order. So can you see this? 16, 44, 83. Okay, now 7 is taking as a sorted element. Okay, now the 7 is picked out here. Okay, 7 is picked out here. This 7 is compared to the element 83. So we suddenly we do not need any change, okay, because we have some elements. So the 7 is compared to the next element as 44. The position will be changed. Now again the 7 is compared to the 16. Now the 83 position is placed here. Okay, the 83 position is placed here, 44 is in here, 16 is here, the 7 is in the form of first element. Okay, let me see. First of all, 83 is placed here. The next step is 44 is in the form of correct position. So the next step is 7 is placed here. Okay, this is in the correct order. So 7, 16, 14, 83. Okay, these are the sorted sublist element. Then 67, 21, 34, 45, 10. These are in the unsorted sublist. Okay. Okay, now we pick out the element 67. Now again we are going to compare with the first element 83. So 83 is a big element, so the 67 is placed in the position of 83. 83 is placed in the position of 67. Okay, now we can interchange it. So this is in the 67 is placed in the position of 83. So this is in the correct order. Okay, is placed here. So the next element is 21. Okay, now these are the sorted sublist, these are the unsorted sublist. Okay, again we repeat the same step till the end. We get the proper ascending order list. Okay, 21 is compared to the 21 is compared to the element 83, after that 67, after that 44, after that 16, after that 7. Here these steps, these two elements, it need not do any change because 21 is a big element. So which one is the correct place to place the element of 21? Means 44 is the correct position to place the element of 21. Okay, now we can place 21 is placed in the position of 44. Okay, 44 is placed at the next position of 67. Then 67 is placed on the 83 position. 83 is placed on the 21 position. Okay, now these are the sorted sublist, these are the unsorted sublist. Now we can pick out the element of 34. Okay, Now here I am going to repeat the same step again. 34 is compared to 83, then 67, then 44, then 21, 16, 7. Okay, here the 34 is placed on the correct position of 44. Okay, this is the correct position. Now again we do the step, that is we can pick up the element of 45. We repeat the same step again. Okay, we repeat the same step again, that is 83, 67, 44. Now the correct place of 45 is 67. Okay, again we start the step, that is 10. Similarly, the 10 is placed on the position of 16. Okay, now the 10 is placed in the position of 16. So this is the position of putting 10. Okay, this is in the correct order. Now we got the set of elements in the sorted position. At the end of the pass, the insertion sort algorithm gives the sorted output in ascending order as shown below. So this is our result. This is in the correct ascending order. Okay, now we move to the topic as the insertion sort. Insertion sort is a simple sorting algorithm. Okay, insertion sort is a simple sorting algorithm. It works by taking elements from the list one by one and inserting in their correct position into a new sorted list. Okay, inserting a correct position into a new sorted list. The third point is, this algorithm builds the final sorted array at the end. Okay, we all are seeing these points in the example. This algorithm uses n-1 number of passes to get the final sorted list as per the previous algorithm as we have discussed. Okay, so this is the pseudocode for insertion sort. Pseudocode means false code. The first step is, if it is the first element, it is already sorted. Then after that, pick the next element. The next element is compared with the sorted sublist elements. After that, shift all the elements in the sorted sublist that is greater than the value to be sorted. Okay, if the element is greater than the sublist value, the element should be changed. If it is lesser than the unsorted sublist, means it need not be any change. Okay, now after that, insert the correct value in the correct position. Repeat until list is sorted. Okay, this is the false code of insertion sort. After that, this is the example. It is located on our book at the page number 41. I think it is difficult to understand to you. Okay, then only I can simplify the steps one by one. After that, I will explain to you. Okay, here take the element in this order, just interchange it. Okay, this is the position of the tablet column. It is very simple, but it is quite difficult because it look very difficult in the tablet column. At the end of the pass, the insertion sort algorithm gives the sorted output in ascending order as shown below. Okay, this is the final result of insertion sort. Hope you can understand the concept now. Thank you for watching this video.